Hello everybody, thanks for joining us today. This is a brief virtual poster presentation for the 2021 Lunar Surface Science Workshop of a poster entitled In Situ Measurement of Lunar Dust Plume Migration. My name is Jason Mazilis. I'm the principal investigator, and if you have any questions at all about the payload, or in particular, if you're with obviously the lunar science community, we would like to hear your ideas on our particle sensor system. And if you have any thoughts or, I don't know, different measurements you would like to see integrated into this lunar payload device, let us know, please. All right. So Lunar ExoCam is a payload that is being funded with a generous grant right now from the NASA Flight Opportunities Program. And it is a remotely deployable sensor and payload device. Basically, there's an ejection system, and then there is a camera and sensor module. And that's the part that you see falling off of the rocket here in this lovely visual. And we're going to be flying that on a Maston Zodiac suborbital test vehicle in October. And we're going to launch 2 of these camera sensor payloads off the rocket. One will be from 25 meters, another from 15 meters. And each Lunar ExoCam payload complement is, there's going to be one 360-degree field of view HD camera, video camera at 30 frames per second. So it basically sees the entire spherical format. And there's going to be a particle sensor system with that. We're going to get to that in a bit, but just to show you, this is how the 2 cameras are going to be mounted on the Zodiac. And the way it works, and generally how this payload works, is as a lunar lander, or in this case our terrestrial Zodiac lander, is coming down for landing. That little animation there is how the camera basically is going to eject from the rocket while it's in descent, and it's going to land, and you'll see it's in the plume in this next slide. So you can see a bit better here. We have now landed in the plume that's being cast out from all the regolith that's getting dispersed from the thrust of the engine during final descent here. And this is where it gets really helpful, because we're going to have particle sensors covering this whole system. And this is something that's never been measured before. There's never been any in situ, direct measurement of this plume migration on the lunar surface. So the camera design, it's a GoPro Max. It's a standard, it's a newer model that GoPro put out that basically, as I said, covers a full 360-degree spherical view. So every angle simultaneously. Because of that, the design of the payload itself can be very simple. There's no moving parts. It's just this basic wire cage, and it protects it no matter what angle it lands. We've tried to break this thing. It's surprisingly tough. We've dropped it from over 50 meters height. We've tested it. It's crossed 50 Gs, but we haven't managed to get it to break 100 G impact yet. And we're actually toughening it up even more before the flight test. So this is actually an early iteration you're looking at. So this is, and you can see in the bottom right there, it's about the size of a basketball. And then the particle sensor system, which is not pictured in the previous photo because we're still building it, is being constructed by Arizona State University. And like the camera, there's going to be these, it's going to be full spherical field of view, if you will, of the sensor system. So no matter how this lands, these little piezoelectric sensors are going to be on all sides, and they're going to record, each of those is actually going to record into a separate data channel. So this is the kind of stuff we really would love to get feedback from the lunar science community, if you feel this is going to be useful, or ways we can improve it, what kind of resolution you'd like to see this data at. Yeah, here's just a quick shot of this thing in construction. This is an earlier shot. Things have tightened up quite a bit. And that's it. It is time to fly. So thank you very much for watching. Again, I welcome your thoughts. The whole team welcomes your thoughts at the email below. And enjoy the rest of the conference. Thank you.